What's going on, guys? In this video we are going to see logic laws. When we try to prove something in discrete math, we use the truth table, but sometimes it's very long, right? So they have created some logic laws. It makes the proof simpler. It just reduces the steps. Now here we are going to see all the laws, and first thing is we are going to see these two new statements. Here this is true. We already know this, true and false. And this can be said as always 1. If it's true, it means always 1. And if it's false, it means always 0. That's true can be also written as this long leg like this. And false can be written as the opposite direction of true, like this. Okay, now let's go ahead and see some laws. The first law is identity law. Identity law says when we have P or false, that is equivalent to P. And when we have P and true, that is also equivalent to P. Here they say this one identity law because we get the same result, or we can say identical statements. And the next law is domination law. When we have P and F, that is equivalent to F. And when we have P or true, that is equivalent to true. So here this is called domination law because the letters dominate the statements. So this is, here the letters are dominating the statement. Now let's go ahead and try this problem. Here the question is asking, prove this P or false and Q or T is equal to true. Now every time whenever apply some laws, we have to mention that one. So here P or false. If you look at this one, P or false is equal to P, right? So that goes under identity law. So we can rewrite this one as P and Q or T. Each time when we apply a law, we have to mention right here. We used identity law. So we have to write identity. And the next thing is Q or T. Now let's see where's Q or T. Q or T goes under here. It's true. So we put P and true. This goes under domination law. Domination. And the next thing is P and T. P and T is equal to P. But this is the final. But let's go ahead and mention this one. This goes under identity law. Identity, but this final results is not equivalent to here because they have asked us to prove this whole thing is equal to true, but we got P. It means this is not equivalent to true. Okay, sometimes we will not get the expected results. It means that's not true. Now let's go ahead and see the next laws. The next law is double negation. Like when you negate something 2 times, that's going to be equivalent to, it's like the thing. Like for example, this is like intuitive. If you negate, this is going to be not P. If you negate not P, not P, that's equal to P. Okay. And De Morgan's theorem, you guys may already know this. When we have like a not P and Q, that can be written as not P, and this one will change into or and not Q. And for this one in the other way, like this will goes like not P, and this will turn into and not Q. This is the De Morgan's theorem. Now let's go ahead and try this proof. Here they ask us to prove not P and not Q is equivalent to P or Q. The first thing is, if you notice, this is look like a De Morgan's theorem because not, we have a and statement that goes on the first law. So when we have this first law, we can expand this one as not P, and this will turn into or and not Q. Each time we have to mention what law did we use. This is De Morgan's theorem. Now the next thing is not. We can apply the double negation. Not P is equal to P, or not Q is equal to Q. So this is double negation. So we proved this one. Okay. We proved the whole thing is equal to P or Q. That's what they asked for. Let's look at the next laws. We have the distribution laws. Distribution law says when we have P and Q or R, it can be written as P and Q or Q and actually P and R. P and R. Now if you remember this one, when we have something like this 4A plus B, this can be written as 4A plus 4B. If you notice this pattern, it's similar to that, right? And also this one also same thing. When we have P or Q, this can be written as P or Q and P or R. Okay, these are the distributive laws. The next thing is absorption laws. Absorption law says when we have P and P or Q, that is equal to P, and when we have P or P and Q, that's also equal to P. Now let's try to simplify this one. So here they ask to simplify. The first thing we can notice is the double negation. So let's go ahead and get rid of all this double negation. So double negation of P is equal to P or, and P or F, and here also we have a double negation. We can get rid of that one, and we have to mention this is double negation. Now the next thing is P or F and Q. P or F and Q. So this one, let's try identity law. Identity law, let's go ahead and take a look at that. Identity law says P or F is equal to P. P or true is equal to false. So like P of F is equal to P. P and F is equal to P. Both of them are P. Right? So let's look at this one. P or F. P or F is equal to P. So we can replace that one with P. P or P and Q. Okay, this is identity and P and Q. What is P and Q? Like absorption law says P or P and Q is equal to P. So the whole thing is equal to P. Now this is absorption. So this is the simple version of this equation, and that's how we do that. And there are more laws than this. I'm going to put that one in my next video. Don't forget to watch that one, and don't forget to subscribe. There are more discrete math videos in my playlist. You can go ahead and watch it, and see you next time.